Okay, so here we go for part 3 of our revision. Now, number 3, list the proper subsets of set M, 1, 3, 6, and 8. Now, proper subsets, they are basically sets which are not exactly the original set, but they are subsets of it. So if I take, for example, just 1, that would be a proper subset. If I take 1 and 3, that would be a proper subset. If I take 6 and 8, that would also be a proper subset. If I take 1, 3, 6, and 8, it's not a proper subset because I've taken all of the elements. So, well, let's just list them here. Well, first, the sets in which I only have one number. So set with only 1, set with only 3, set with only 6, and set with only 8. Now what about pairs? I can combine 1 and 3. I can get another set with 1 and 6. I can get 1 and 8. Now I can make different pairs, so 3 and 6. I can do 3 and 8. I can do 6 and 8. We're done with the pairs. The order does not matter. Okay, so the order doesn't matter. Now, 1, 3, and 6. Now the triplets. 1, 3, 6. 1, 3, 8. 1, 6, 8. And 3, 6, 8. That should be all of them. If I take any other set, it seems like it wouldn't be a proper subset. I would have to take all of the elements into consideration. Now, the only set which I have not drawn here on purpose is the empty set, right? Because it's a proper subset of any set. You can get empty from any set. That's right. Okay, so number 3 is done, and we have 1, 2, 3, 6, 9, 12, 15 different subsets, proper subsets. If I took only subsets without proper, then I would also have this one. This would also be a possibility. Anyway, number 4 now. True or false? The natural numbers are a subset of our positive integers. Well, this is not going to be true because the natural numbers, they contain 0, right? So they begin at 0, 1, 2, 3, 4, and so forth, up to infinity. Now, the positive integers, they start at 1. So it's false. Now, rational numbers are a subset of the integer numbers. No, it's quite the contrary, right? The integer numbers, they are a subset of the rational numbers. That's false. We're going to have loads of rational numbers which are not integers, right? For example, just in one of the previous examples, we saw that 1.3 is indeed a rational number because 1.3 can be written as 13 over 10, which is a ratio of 2 integer numbers, right? However, 1.3 is not integer. Okay, so that's false. Number 5. List set A. So we have a Venn diagram here. Now list set A. So if we look at this Venn diagram, and again, those videos, you're expected to stop before the beginning and try and do the exercises yourself, and then you can check the answers later. Now, set A, I've got 1, 2, 3, 4, and 5. What's in here in the intersection is also in set A, right? It's in set B as well, but doesn't matter. It's in set A, so if I want to list set A, that's it. Now, what about set B? Well, 1, 2, and 7. That's what we have inside of our set here. 1, 2, and 7. This is set B. What about set U? Now set U is everything that we have. everything that we have inside of the rectangle. So it's basically 1, 2, 3, 4, 5, 6, 7. It's all numbers up to positive integers up to 7. It's 1, 2, 3, 4, 5, 6, 7. It would also not be wrong, however I wouldn't expect you to come up with this, but it wouldn't be wrong if you wanted to write, for example, x such that x is less or equal than 7 and x is a positive integer. That would be okay, that would be amazing actually, right? It's neat, it's nice, beautiful, succinct. Next one, set A union B. So it's everything that we have in at least one of those sets. So if one of them has it, the union will have it. So 1, 2, 3, 4, 5, we have those in A, and 7, which we don't have in A. So it's 1, 2, 3, 4, 5, and 7. No 6. Why? Because 6 is in neither A or B. Now what about the intersection? Intersection is what they both have in common, right? Here we're considering what both of them have. Here we're considering just one. Either. This is either. Right? If either one of them has it, and here only if both of them have it. So here it's or, if A or B have it, and here it's and, if A and B have it, both of them have it. So what do A and B have in common? 1 and 2, that's all. So in between here, only 1 and 2. Now, letter B, find the number of elements on A. Well, A is 1, 2, 3, 4, 5, so that's 5. Number of elements on B, that's 3. Number of elements in the union, this is our union, so we have 6. And there you go.